All right, so I'm about to show you a rather difficult stoichiometry problem, and this one is involving solutions. And so, as I'm going through this, I want you to attempt to follow along from a conceptual standpoint, calculate things with me, make sure that you understand why I'm doing things as I'm doing them. If you don't, this would be a great question or set of questions to ask. Why did I do that at this point and that sort of thing during class on Friday. So as we're going through this, yeah, keep your brains turned on, basically. That's my bottom line. Okay, so first off, we're going to balance this equation. So if you notice here, we have two sodiums on this side, or one sodium on this side, two sodiums on this side. And I'm going to balance sodium first, and then go ahead and balance probably hydrogen or oxygen last, and hydrogen and carbon somewhere in the middle. So looking at this one, I see that I'm going to need two of these here. So let's go ahead, at least. So let's go ahead and put a 2 there. Now I've got two sodiums. Uh, there's two hydrogen here, two hydrogen here. So there are four hydrogen on this side. So it looks like I'm going to need a 2 there. So let's go ahead and put that there. Now, I also have two carbons. On this side, I have one carbon, so it looks like I might need a 2 here as well. On this side, I have oxygen, 3 oxygen plus 4 oxygen. Oh, wait, 2 times 3 is 6 oxygen, right? Plus 4 oxygen, so that's 10 on this side. On this side, I've got 4. With this 2 here, I've got another 4, and with this 2 here, I've got 10. So I think this is balanced, actually. 2, 2, 2, 4, 4. Carbon is 2, carbon is 2, oxygen is 10. So my balanced chemical equation is 2NaHCO3. I'm going to just leave off the states of matter plus H2SO4. Now I'm going to put them in there. That way it's correct. AQ goes to form Na2SO4 AQ plus 2CO2 plus 2O G gas plus 2H2O liquid. All right, so that's just balancing. Let's go ahead and go down to the second problem. So if 10 milliliters of a 5.55 molar sodium carbonate solution were mixed with 5.67 milliliters of 4.67 molar sulfuric acid solution, what is the limiting reactant? So this method I'm going to show you is one of the possible routes we can go. What I'm going to do is go from milliliters of this and moles of, and the concentration to moles of water and see which one is creating less water. So we start with what's given, and I'm going to convert these automatically into liters. So 0.0105 liters of NaCO3. Then I'm going to use the concentration to convert that into moles. So I see it's 5.55 mole per 1 liter from this concentration right there. And then I'm going to convert it from sodium carbonate into H2O. So I see from the balanced chemical equation, I'm going to get 2 for every 2 sodium carbonate. So for every 2 NaCO3, I'm going to get 2 H2O. And I'm going to leave it in moles here, actually. Okay, so we can cancel the sodium carbonate here. We can cancel the 2 actually here and here. And we're going to go see how much water we get. So in moles, we're just going to stop at moles. We're not even going to go to mass or to concentration units. So getting out my calculator. Where's my calculator? There it is. Okay, so 0.0105 times 0.8. Oh wait, that would be 5.55 equals, it looks like this will be 0.0528, so 0.0528 mole of H2O. Now let's do the same thing using our other reactant, our sulfuric acid, and see how much that makes. So again, going over to our sulfuric acid, we see that we have 0.00567 liters times, and now we need to use the, of H2SO4, need to call what it is, times the concentration, 4.67 mole per 1 liter, times, using the stoichiometric coefficient to convert from moles of sulfuric acid to moles of water. We see that we put sulfuric acid on the bottom, and there's 1 H2SO4 for every 2 H2O. Notice that our sulfuric acid will cancel, our liters will cancel, and so we'll be units of moles of H2O. And so bringing up our calculator here, right there, start plugging in the numbers. 0.00567 times 4.67 times 2 is equal to 0.0530, okay? Equals 0.0530 mole of H2O. So when we ask what is the limiting reactant here, well, we look at this. This is smaller. This is a smaller amount of product, and so our limiting reactant is our sodium carbonate. Now, going to one final question we could ask: how much sulfuric acid is still left over once this is done? So looking at that, let's actually go ahead and copy this bit over to another set. So here we go. Give me just a second. I'm going to pause and copy that over.